Welcome everyone. I am back with my webinar series, webinar number 16. It is on electrical safety for maintenance engineers in utility and industries. Safety is my favorite baby and I love it a lot. Dear all, every time when we come across, we hear some news of any electrical accidents. It gives us pain. We feel helpless because it is not a death of the person of that accident victim. There is death of more person associated with that victim in the family. We feel guilty. It forces us to ponder over the reasons, causes of this repeated accident. Implementation of technology to save people, property, and equipment. We think about the mechanism we need to enforce the prevailing regulations of safety. Keeping in view above factors and facts, I requested expert trainer of safety in Hitachi Energy, Harsh D Ramaiya, to spare his invaluable time. And he immediately accepted the same and he is with me right now. Before I invite him, I would like to start with thanksgiving as I usually do. I am thankful to Almighty, my parents, my family, my wife, my son, my mentors, respected PP Vai Saab, KK Murthy Saab, KK Gupta ji, and K Mittal ji, P Ramachandran sir, Hitesh Chauhan ji, Dr Kamal Bansal. My friends and well-wishers, Saket ji, Arvind Tukral ji, Dr Vikas SK Patra ji. My team working day and night for me, Gulab and Ramdhani. Now, time to give a brief introduction about the today presenter, Harsh D Ramaiya. He is a person who did his electrical engineering from Sardar Vallabhbhai Patel Institute of Technology in 2001. He did his master in electrical power engineering with business from UK in 2007. He has varied experience of 20 years, especially in the field of switchgears and protection. He has worked in Jyoti switchgears, Alcon engineers, and with ABB medium voltage divisions. He has worked in UK for 10 years for clients like National Grids in England, Scottish Power in Scotland, and Scottish and Southern Energy UK in the field of substation secondary engineering. He is currently working as a senior technical consultant with Hitachi Energy, and he carries out steady state and transient power system studies like protection coordination, relay setting, harmonic analysis, motor starting analysis, etc. He has very special inclination towards electrical safety and he is a specialist in arc flash studies for industries and the utility. He is a master trainer for electrical safety for PICW at Hitachi Energy. Now, without much ado, I would like to hand over this stage to Harsh D Ramaiya ji and set this stage on fire with your knowledge you have. Welcome, sir.
Thank you very much, Rajesh ji, and I really feel quite privileged. I feel blessed to, as you invited me on the stage, and I really feel, yes, thank you, so that as you very rightly said, that when we hear the news in the newspaper saying a linesman was doing some work on a line, or this person X was working in an industry and either he got electrocuted or he got burned, it really pains. It really pains us. And we start wondering, where are we lagging? Where is it that we are not giving our best? Because we, as technologically so advanced. In fact, today you buy that, in Gujarat we call it as khari singh, jo singh aati hai. You buy it through Paytm. That 5 rupee, 10 rupee, you're transacting it through Paytm. So where are we as engineers? We are, probably, what is it that we are missing out? So thank you very much, sir. Thank you for inviting me. Let me share my screen here. Let me know if you are able to see my screen. I will, okay. To share sound. Okay.
Perfectly
Okay.
okay. Perfectly okay.
Okay, fine. You can see my screen, right, sir?
Yes, yes, please go ahead.
Okay, thank you. So thank you everybody for attending this. The idea about this particular session is to share with you the best practices that we at Hitachi Energy we adopt during our maintenance services operation activities, so as to safeguard our people from any kind of hazard. Okay. About myself, Rajesh ji has very well, briefed up. So yes, I have worked in India. I have worked in UK. In both places, I learned everywhere. I learned bits and pieces of safety. And today I've just clubbed a lot of this knowledge, and I'm just sharing with you. Just 2 minutes speaking about my organization. I work for Hitachi Energy. Hitachi Energy is basically a joint venture between ABB and Hitachi. So when high voltage business of ABB Group, also known as ABB Power Grids, it came together with Hitachi. This led to formation of Hitachi Energy. Our CEO, Claudio Ficin, is our CEO, and he is based in Switzerland, in Zurich. The purpose of the organization is by collaborating with customers and partners like you, we are advancing towards a flexible, secure, and sustainable energy future for all, for today, for tomorrow, and for generations to come. The Hitachi Energy serves customer in utility, industry, services across the value chain. Together with our customers and partners, we pioneer technologies and enable the digital transformation required to accelerate the energy transition towards a carbon neutral future. Now, I am from this Power Consulting PC Solutions. So this Power Consulting PC is the Power System Analysis and Consulting Center for Hitachi Energy worldwide. We have been providing consulting services to electrical industry worldwide for over 50 years. Our personnel have expertise in all areas of electrical power transmission and distribution, including system analysis, planning, and operational studies. As a team member of Power Consulting, I partner with my customers to provide them a solution on power quality, harmonic issues, protection coordination, substation design and engineering, renewable energy integration, the best solutions, the blackout tripping issues, grid code requirements, and my favorite subject, arc flash studies. So now talking about maintenance, what are the safety concerns during maintenance? Who is responsible for the safety of the people? I would say safety is responsibility of all members of the working party who are working on the job. So everyone has a moral responsibility to keep themselves and other team members safe. Of course, there will be an overall in charge. Now, in my organization, we use a term called PICW. Okay, so it's a person in charge of work, right? So he is overall in charge of the work, and he has got the responsibility as well as authority. Why? He needs to ensure that the system remains safe, the people remain safe. Okay, and this person, who is a PICW, like a person in charge person, you could have different terms. Different organizations have different terms. Some people call it a supervisor, some people call it an area manager. You could have any term. Basically, the idea is same. He is the person who is in charge of the work. Now, this gentleman or the lady, is an electrically authorized person by a senior management who is ultimately responsible for the health and safety of the work team. The person in charge must carry out all necessary steps so as to create a safe working environment of the place where they are going to work or do the maintenance. So before we understand, before we go into the steps of what is required or how we do it, let's understand what steps should be taken to work safely while carrying out the O&M activity. We must understand the electrical hazard and risk while carrying out these activities. So when I talk of electrical hazards, so dangers that are associated with electricity while carrying out a maintenance activity. Of course, whenever you work on a machine or you work on a line, okay, there are other dangers. The dangers could be, you're working at a height, so there is a danger you fall down and you break your bones. That's a danger. Okay, you may be working with a rotating machine. The rotational speed or the power of the machine is, danger, but that's again a mechanical stuff. What we will be focusing today would be the electrical risk. Okay, so dangers associated with electricity while carrying out the maintenance activity. Of course, shock. There is always a chance whenever you're working with, the control system, control panels. Okay, you could be, accidentally touching any exposed live conductor, like a positive of the battery, or the positive the power supply, 110 volt AC, 220 volt AC, or 220 volt DC, either AC or DC. So you could get, a shock. There is always a chance when you work with the switch gears, when you work with MCC boards, the switch boards, right? There is always a chance of electrocution if you infringe the safety distances. Yes, electrocution. Then there is something called as an arc flash. We'll just see it in the next slide, what is arc flash. But there are dangers of arc flash. Then arc blast, which is associated with the arc flash. And there are other effects. Now, when I say other effects, these are probably the non-electrical ones, but they are also, something that you need to consider, like heating of cables and equipment causing fire. Of course, it's a design issue. When it becomes this, it's a design or a maintenance issue, or equipment being very warm or hot to touch while doing maintenance. A thermal effect, non-electrical. The equipment could have sharp objects, the spring charge, they could be heavy, it could be at a height where it could just pose a danger of falling on somebody. But these are other mechanical effects. So concentrating on to electrical one, we have here shock and electrocution and arc flash and arc blast. Okay, so what we need to do is, first thing we need to do is we need to understand what are these. Now, when I say shock or electrocution, probably everybody knows what is a shock. Most of us who are attending this training in their lifetime, most of them, Rajesh sir, when I'm a master PSCW trainer in my organization. That means whenever any new person joins my organization, they need to undergo this electrical safety induction training. And I did find some nice people who said, sir, I've never got electric shock. So it was a little bit surprised to me. I get a shock, every 2-3 years in my own house when some switch fails or something, at that time I do get a shock. But of course, for those who have had a shock, it is painful, it's not pleasant. Probably something to add on is anything over 10 milliampere, if sustained, could be fatal. That means if the current that is passing through your body is over 10 milliampere, and if it is allowed to sustain, okay, for whatever reason, you could not maybe pull back your hand, or it's more than 10 milliamperes, right? Then there is always a chance it could be fatal. Less than 10, there is the probability that you have the power. It's high probability you have the power to let go. It's the natural reflex action of the body, and you will really let go. Anything less than 10. Over 10, it becomes a thing of a concern. Okay, when I say it's a probability, it's not for sure 10 milliamperes or 11. It's a probability, the chances over 10. So shock, electrocution, when I say electrocution, it's something that leads to a fatality. Okay, so this is something people know. So when I say arc flash, what exactly is an arc flash? Rather than me telling you what is an arc flash, let me just show you a demo or a video, a real life video of what exactly is an arc flash. Now this video I've taken from YouTube. You go on YouTube, you'll find thousands of videos, which makes me feel concerned. Oh, there are so many incidences of arc flash. Are we not really learning out of it? So let me play this video and show you how dangerous is, or what exactly is an arc flash. Okay, so of course, now arc flash is something really, really serious. It is something to think about. It may not happen, but if it happens, the consequences are devastating. So what is this arc flash? If I just slowly go through this one, so this is in this example, I can just assume this gentleman was trying to either rack in or rack out his switch gear. Okay, and while doing it, something happened, something went wrong, right? And because of that, there was a big explosion. Okay, so electric arc occurred during this time. It occurred in a space what was previously called air, right? And it happens when the voltage between the 2 points exceeds the dielectric strength of the air. Now, what is the result? The result is the light that you can see, the heat that you can see. This is emitted by the explosion. This is called as an arc flash. Now, along with that, there is always a chance that there is some kind of pressure wave that is also emitted. Now, when this pressure wave is emitted, we call it as an arc blast. It is exactly like, when there is a blast, as you see it in the news or the movies. What is the effect? The effect is very severe. Okay, so these are the pressure wave. Now this arc flash releases concentrated radiant energy. It releases concentrated radiant energy as high as 4 times the temperature of the sun's surface. Now, believe me, my friends, when in summer, when we go out, our skin just burns with the sunlight standing on the earth. If you are in front of an energy which is 4 times the temperature of the sun's surface, it can just cause metal to melt. It can cause very severe burn injuries leading to fatalities. Okay, the light as you see it in the explosion, these are the UV lights that are radiated out of it, and this has the capability to blind you, maybe permanent, maybe temporary. Okay, along with that, you hear sound. At momentary, it is an explosion, so there would be a sound. The sound can cause deafness, and even the molten metal particles can fly out at a very, very, very high speed, causing external and internal injuries. So arc flash is a real serious concern whenever you are working with a switchboard. It is a real kind of a concern. Whenever, not even necessarily any live equipment, but ideally more probability of this thing is more with the switchboard, whether it is the LV switchboard or it is a MV switchboard, or even why not be an outside AIS. Okay. Now, when such arc flash happens, okay, what are the consequences? Okay, I have some picture here. The picture could be disturbing. If you have light heart, just don't see. I'll tell you when I move my slide ahead. Okay, so here's the picture. So as you can see, this gentleman who has been working on this particular switchboard, let me just use my laser pointer. Okay, he has been working on a low voltage switchboard, fine, and it's been trying to do something, and for some reason there was an arc flash. Of course, this gentleman burned his hand, burned his face. Okay, so it led to an injury. Now, even if these arc flashes don't injure a person, there is always a damage to the equipment, which causes the downtime and causes a lot of economic, in terms of financial losses, okay, economical losses. So the question becomes, what do we do to protect ourselves from this electrocution or shocks or arc flash or arc blast? So I move on to my next slide here. So this is a 7 steps to safety that we at Hitachi Energy adopt at our customer premises. Now over here, I did see some of you were our customers here. So you would have seen if the service person has come to your site, they would have surely followed this process. Now this is nothing but Hitachi Energy's life-saving rule when working on electricity. For us, it's mandatory. There is no ifs, no buts. And this is universal. When I say universal, it's universal across the globe. Whether there is a Hitachi Energy employee from Japan, there is a Hitachi Energy from India, or Hitachi Energy employee in USA. They follow these 7 steps to save life. Okay, this is mandatory, and I'll be going through each and every step, explaining what is our process. Either all 7, or some, maybe 6, maybe 5, or even maybe 10. Now this depends upon what is your work process. Depends upon, you know, customer to customer, whether you are a utility, whether you are an industry. But however, I believe this will be applicable to large spectrum of the audiences, other than those who are working on hot works like 400 kV repair of lines. So that's a special case. Okay, but if you are working on 11 kV switchboard, 415 volt switchboard, and you're not working on live, I think this steps easily suits your industry, suits yourself. Okay, and if you follow this, you know, I can guarantee you, you know, you will 99.9999% safeguard from any kind of occurrence. I'm not saying from arc flash, from occurrence of an arc flash or occurrence of a electric shock. So let's understand these 7 steps. And see, Rajesh did definitely mentioned you that I'm a electrical safety PSCW trainer, and this 7 step is just a small part of the training. So in our organization, whenever any new employee, you know, he or she joins in, if they are going to work on electrical network, we give them some kind of electrical induction training, which is a 16 hours face-to-face. It's mandatory. Okay, and this 7 step becomes a small part of it. There's a lot more to it to really understand electrical safety. This is just a small part of it. Okay, so talking about step 1, what is step 1? Step 1 is you evaluate your work and do an on-site risk assessment or hazard analysis. Okay, so what does it mean? So basically it means that whenever you're working, be in possession of a clear work order, be in possession of clear procedure to carry out the work, right? You identify the hazards, okay, assess the risk of the identified hazard. Okay, so normally what happens is, you know, you are specialized in probably servicing of a motor or a transformer or a line or a switch gear, right? So what you have is a standard risk assessment for that thing. What you also need to do is you also need to assess the risk of the identified hazard, do an on-site risk assessment at the time, you know, at the time when you are going to probably start your maintenance. You do an on-site. So these 2 risk assessments are a bit different. One thing is very, you know, generic, that, you know, probably you have prepared it at a planning stage. Now what you're doing is preparing a risk assessment at the execution stage. Why? Because when you are executing some kind of a maintenance activity, there could be a change in environment. It could be possible that there is some other contractor who is coming and working next to you, or there is some other activity of the client, or there are 2 parties working adjacent, or you're working outside, the climatic condition changes, the weather's no more the same as what you had planned during your planning stage. Okay, so you need to perform an on-site risk assessment, and that all becomes a part of step 1, that you evaluate your work, do an on-site risk assessment. Okay, also sometimes if you are a client and you have some contractors, right, you ensure the competency of worker. If you are the contractor, you are going to a client's place and you are being given some helping hand, you ensure the competency of the worker. You know, just don't assume that these people who are working with me, they understand everything. No, There has to be a very clear communication. You must know you are the person who is in charge for the work. You are the person who is in charge for the health and safety of you and your teammates. So you need to check the competencies of the worker. You need to check if the tools have been provided by the client, or you are the client and the, the person who is coming to work on your site to assist you to carry out a maintenance. They have proper tools for the right job. Okay, you engage the person responsible for the electrical equipment or system to review the single line diagrams, switching plans, etc. Like, don't jump onto directly switchboards or equipment. Try to understand how the system is. Is there any way you could, anything pose danger to you? What are the different hazards? So just don't follow the single line diagram that may be marked on the panel. Things could have changed. Look for some single line diagrams, speak to the responsible people, look at the switching plan, look at the schematics, look at any documentation that may be available on your site. Okay, based on that, you decide the appropriate work methodology, how you are going to do it. You determine and select the right personal protective equipment that you will be probably wearing, okay, or personal protective tools that you will be using. So you determine the right. Now, determination of PPE itself is a big subject, but I'm not covering it right now. But you should determine and select the right rated PPE. Okay, as you have seen in the earlier video, how dangerous was the arc flash, and arc flash is never the same at switchboard 1 and switchboard 2. Both switchboard could have different arc flash incident energies. Both can emit different amount of heat energies, what we call as an incident energy. So you really need to determine and select the right PP for this particular job. Once you have done this, the next step is you initiate the permit to work. You start initiating this permit to work documentation. Okay. Step 2. Step 2 is you clearly identify the work location and the equipment. So basically what you do here is you define your work area, you barricade it, you label the equipments. That is, once you have identified your equipment, ensure that your working area is totally barricaded and risk is posted in terms of label, notice, etc. The idea here is people must know you are working in this particular area and nobody should interfere with those things without your knowledge. Okay. At the same time, you are also telling other people that, okay, look, some work isn't going on and this is dangerous for you. So basically what you're trying to do is you are identifying the work location area. Check label of the equipments where you are going to work. Do not trust just the handwritten labeling. Double check information through single line diagrams, drawings, layouts, and other documentation available. Now see, all these procedures, some of them may be applicable to if you are the client. Some of them may be applicable if you are like a third-party contractor or a service engineers like or manufacturers like us. Okay, but we do have manufacturing and servicing both together. Okay, so we have our own site. So this is very composite. Our process is very composite. You couldn't have some parts and you couldn't have some parts, but idea remains the same. Okay, use temporary signs to mark the equipment while the work is going on. So basically all you are doing is barricading, especially when you are in an outdoor switchgear, outdoor switchyard. There are a number of bays. Okay, even in the indoor switchyard, if you are working behind the equipment, most equipment these days are properly labeled on front and rear. But sometimes when you work on very old or some sites could have labeling issue. So it's very important that you really identify the place you are working and avoid, so that it avoids you going into a wrong panel, because then it could just be a catastrophe. And these incidents are happening. Believe me, my friends, these incidents are happening where people are going and starting to work in a live panel, which is just adjacent to the panel they were supposed to work in. Why? Because they did not clearly, demarcate the area where they were working. Step 3. Step 3 is disconnecting electrical sources. Of course, we as Hitachi Energy, we have a strict policy that we do not work on live equipments directly. And as I said, believe me, other than those at high voltages, extra high voltages, if you really look into the risk involved versus the economic gains of doing a live maintenance, the risk involved are really high. Okay, so other than high voltages and extra high voltages, so for 415 volts boards, 11 kV, there is no good economic benefits compared to working on a dead portion of the equipment. When I say dead portion, I don't mean to completely switch off the substation or completely switch off the switchboard. You are just trying to disconnect the equipment what you are going to work on, right? So step 3 is disconnect electrical sources. Now this step 3 is a 2-step method. Step 1 is disconnection, and step 2 is securing against reconnection, right? Now my belief is, most there are many, I wouldn't say use the word most, but there are many or few who concentrate on step 3A, and there are few in whose SOP both steps are there, but they violate step 3B as per their SOP. But both are important. You need to disconnect electrical sources and you need to secure against reconnection. So going into disconnecting, basically the equipment or the system where the work is to be carried out, it could be your motor, it could be a transformer, it could be maybe a generator, it could be a distribution line, it could be your RMUs, it could be your switchboards, whatever it is. The equipment or system where the work is to be carried out must be isolated from all possible points. So when you talk of a motor, it just has one single feeding, right? So you need to isolate that one particular outgoing feeder. But when it comes to transformer, it has got 2 end. If it is a 2-winding transformer, if it's a 3-winding, it's got 3 ended. So you may have 220 by 66 by 33, or 220 by 33 by 415. So all 3 ends must be disconnected, and you must look for any kind of auxiliary sources of supply, back feeds, test points. All those parts must be disconnected, right? And when you talk of disconnection, right, now you could have 2 kind of equipments in your utility or your industry. Okay, so the electrical installation may consist of an EIS switch gear or with some dielectrics like VCBs, oil in the old switch gears, SF6 most common, and these days nitrogen or any other substances, right? To ensure safe disconnection of the system, check for visible cut. If the disconnecting device allows the position of the connecting parts to be visibly checked, the air insulation is considered sufficient if the maximum blade separation has been achieved. And that is only possible probably in the AIS one. Now, you could also have closed devices, what I'm showing here. Now, this is a Hitachi Energy hybrid switchgear. This is a hybrid switchgear wherein you have a circuit breaker, you have a disconnector for the bus side, you have a disconnector on this end for the load side. Okay, you have a CT and even sometimes a VT instead of a bushing here. You could have a bushing with a VT inside installed within it. So this is a hybrid switch gear, right? And when you have such devices, enclosed devices where cutoff cannot be visually verified, of course, these devices do come up with eye view, but manufacturers do advise not to go and look while the system is in live. They have their own safety notices. So at that time, you should have some other safe system for clearly identifying the opening and closing of the position. So idea is look for effective disconnection. Okay, so step 3A, disconnect electrical sources. Going on to step 3B. Step 3B, securing against reconnection, which is nothing but LOTO, lockout, and tag out. Some people call it a lotto. Some, these days I also hear some people calling it low-to-to, which is lockout, tag out, try out. Some people also call it low-to-to-to, lockout, tag out, try out, test out. Different word. Idea is the same. Have a lock, you have a label. That's it. Okay. For safe working condition, it is necessary to secure the installation against any kind of reconnection. And this is what, Rajesh, we were just discussing when we hear this in the paper that there was a linesman on the line and he was doing the maintenance and suddenly got electrocuted. Why did it happen? When he was working on the line, it was disconnected, but it was not secured against reconnection. And that's why you have these issues. So by putting a proper lockout tag out, okay, you can make sure your system is secured against reconnection. Now, Lotto itself is a big subject, how you must do it. I'll just go through some few important points here, or few important tips here. Okay. So for safe working condition, it is necessary to secure the installation against any reconnection of the switching device used to disconnect the installation from the power supplies. Now, what are the causes that can produce reconnection? It could be some technical reasons like a technical failure, like interlock issues. Okay, it could also be a human error, as we just talked about it. It could be miscommunication, or it could be any other unforeseen causes. Okay, now Lotto. Who must apply a Lotto and why is Lotto? So let's first see why Lotto. Why Lotto? So here I have a video which is not an electrical one, which is more like a mechanical one, but the idea and the concept is the same. Okay, so again, the video has a very disturbing view at the end. If you are light-hearted, you don't watch it. I'll let you know when I turn on my next slide. When I turn on to my next slide. Okay, so here I play the video. Okay, you can now have a look back. Basically, what is written here is in a French language, which basically, if I translate it into English, is at stake. So my life is behind this law. Okay. Rajesh, can you confirm if I'm still audible?
Yes, please continue. Very interesting.
Okay. No, I just got your internet connection is poor. So I do have a second standby connection. In case I lose, I'll just jump on to the second one. Okay. Basically, as you can just try to, I tried to realize this video, and what I understood is, this gentleman, he is working behind, he's doing some kind of maintenance behind a mechanically powered equipment, right? Now, as he's working, the operator comes back from the lunch. Probably he has been discussing some football in his lunchtime, right? Okay, so in his mind, he has that football going on in his background. He even sees the maintenance engineer, the operator sees the maintenance engineer behind this object. Okay, but he is still in his thought of football. Okay, he goes back to his place and he tries to turn the switch on. When he turns the switch on, nothing happens. Why? Because the other gentleman, has turned the switch off, powered the main switch off. So this gentleman sees my switch is off. That's why my machine is not working, right? And he goes and turns it on and pushes the button. As soon as he pushes the button, the other gentleman is totally squeezed behind it. So I'm not showing you the face again. Basically, all I'm saying is your life is behind this lock. So why Lotto? Lotto is to protect yourself. Okay, Lotto is to protect yourself. It's not something just because your SOP, standard operating procedure, says that you need to apply a law for fun. No, it's just to protect your own life. Okay. Okay, so securing against reconnection, such equipments are available in the market, as you can see, all the way from the low voltage MCB to the switchgear. Most modern switchgear have, or I would say almost every modern switchgear has a possibility to lock out. Now, this is something which all manufacturers are, putting down in their switchgear panels, or whether it's just a 66 kV circuit breaker or a 400 kV circuit breaker, or a medium voltage 11 or 33 kV indoor. Every manufacturer has given a provision to put a lock on the panel. And for those who are working in an industry where this provision is not there, because olden days it was not there, I'll tell you, it wasn't there. Some switchgear, in that case, take a proactive step. Go ahead, just get maybe a welder and get these kind of arrangement fixed. What you need is simple locking arrangement. That's all what you need. Like how we have that curry in our home, small locking that you can just fix. You can just do the same, as simple as that, and that will really make your system more secure for you to work during the maintenance stage. Now, when you are working in groups, in like it's more than one person, of course there are something called as this is a hasp. What you can see here, it's a hasp, and this allows you to put this kind of hasp in a place where only one lock can be put. So you put a hasp, and number of people who are working can put their own locks. Like this is a Lotto box, this is a hasp, so you can use any of the methods. Okay. Talking about Hitachi, we have a policy. Our best practice is you have one lock, you have one key, and that's for one person. So you have one lock, one key, one person. Why is it that my company is giving me so much privilege? Let's look at a video. This is what I've taken from Nepo. Okay, and so I've just taken it from here, and you can see that. Okay, so it is very clear, if somebody else has put the lock, it is for his safety. It's not good for you. He may even not know you are working behind the system. So it's best is you put your own lock to safeguard yourself. And along with locks, you need to put some tags in, just probably mentioning what kind of work is being done, who's working on this, your contact details, and some additional tags such as, danger, the panel is live, or the panel is earth. Earths are applied. So before, charging, make sure the earths have been removed. So this is step 3, which is isolating all sources of supply and securing against reconnection. Now, once you have done that, you check whether the system is de-energized. Okay, so no circuit should ever be presumed. Don't never presume it that it's dead until you have measured using reliable test equipments that yes, my circuit is dead. And you must always do this. You must always do this before, even in the extra low voltage system, before you touch any of the metallic conductors, before you touch them, make sure you test them that there is no voltages onto it. So use a proper voltage detector equipment before and before using a voltage detector, it is important to check that it's meant for that particular operating voltages. Okay, now the absence of voltage must be verified in all the conductors of the installation. Okay, whether it's an LV, medium voltage or high voltage, check it between phase to phase, phase to neutral, neutral to earth, if neutral and earth are available. Of course, in the low voltage system, you can have all these three. In medium voltage, you check between all the three phases that there is there is an absence of voltage on all the three conductors. So once you have done that, okay, how do you do it? Basically, how do you do it? The voltage detection we adopt is a three-step method. That is, first we check that our voltage detector is actually working. Okay, now for low voltage system, of course, you can go and try to any nearby point to see it's live or not. You can just go to any known sources and you can check. Maybe for high voltage also, if you have an additional bay next to it, you can just go in the proximity and your voltage detector may light up, may sound up. Okay, and you check your voltage detector that it is properly working. Then you measure whether, or you test whether your all the three phases are dead. Okay, and once you do it, recheck it again that okay, it's still working. It wasn't that while trying to measure the voltages on the three phases, my equipment has got damaged. So this is a three-step method that we at Hitachi Energy follow. Okay. Now, once you do that, okay, the next thing before you can touch is earth the system or earth the object that you are going to do the maintenance. Okay. Now, earthing, or in some countries it is called as grounding, it has got two main functions here. First thing is it ensures that if that particular equipment like a transformer or a motor or even a line, it could have some residual energy stored in it. Okay, so that residual energy is discharged, or there could be, in case of a high voltage system, you could have some additional bays next to it, so you could have some kind of induction effect. So these things get, in all these induced currents can get well grounded. So that is one purpose. The second purpose is if the system or equipment gets energized by system voltages. Okay, now it could be, even though we have made sure that we have locked out and tagged out, it could be maybe due to back feeds of test states. It could be due to accidental energization at some point, probably where we have missed out. It could be wrong installations, okay, or it could be live conductor falling at the line crossing. Whatever reason it is, if your system becomes live again, okay, then that part of the system gets totally, the short circuit current gets totally earthed at that point, and it safeguards you. So how does that work? So basically what happens is, if at all you are working on the line and you have shorted all the three parts, or you're working on any equipment you can consider, and you're working on it, and there is a gentleman who is touching it, and when the fault current happens, basically the voltages between the exposed live conductor and the ground is zero, because you have totally short circuited them to the earth where you are standing. And if somebody closes the system, okay, the relay protection will operate and cut off the supply. So that's how it basically works. The question becomes, where and how many grounding equipments do I need to place it? Okay, the question becomes that. So I would say, you first of all, where in the vicinity of the equipment over the power supply. So wherever there are power supplies, you just put next to it, okay, on all sides of the working area. And how many are placed? As many devices as circuit. That means as many grounding devices as the power supplies. Now, if you have a three-ended system, okay, you put four earthing conductors, right? So this is what you do. That will actually safeguard. When what happens is when you're working on a system, and for example, a line span is working on a distribution line, and suddenly somebody, of course, he should ensure that the lines is totally isolated and it's locked out. You have checked the voltage and you have probably earthed it. Now, because in distribution system there's too many connections, if at all accidentally somebody closes, the portion where you're working will be at a ground potential, and where the person is trying to close the circuit, there would be a three-phase fault, and the breaker or the fuses will just blow off and protect the person. But one thing you must remember from the last three steps I talked about, which is disconnection, the voltage verification, and earthing, there are some dangers associated while doing these activities. The dangers are of yourself getting electric shocks during that time, or an event of an arc flash. And why it happens? It may happen of some reasons, like you are operating the disconnector under load. It is an error in communication of the operation, that is the lines are still loaded or the breakers not open and you are still operating the disconnector. It could be error in identifying the devices, okay, or operating an equipment which is actually in a very, very poor condition. So there are always chances that you could be subjected to arc flash or electric shocks. Okay, so what you need to do, you need to ensure that you use the right equipment, and proper measures needs to be considered. Whatever you are doing, use like an insulated, cold rated for the voltage of the installation, wear protective gloves against electrical hazards for suitable voltage level, use an insulating bench or mat, use arc flash clothing, use arc flash shields and safety hard hats, etc. You need to identify what are the risks, and you need to take appropriate actions that way. When we talk of, especially for when we talk of earthing, right? When we talk of sorry, my apologies. When we talk of earthing a system, now what can go wrong is, and this has happened. This has happened because, as I said, because of, especially in the outdoor switch gear, and even in the indoor, people have gone into a wrong panel and did the earthing. They have done the right step 1, 2, 3, 4 correctly for the right panel or the right bay, and step 5 onto the wrong panel or the wrong bay. And what happens is, when you earth a live system, the short circuit occurs between the phase and earth, and the current flows through the earth conductor. Now this produces thermal effect, which is high temperatures, which can burn the ground equipment, or it can give dynamic effects, violent movement, vibrations that can release the grounding clamps of the equipment. So under both these conditions, until the fault is cleared by the system, this keeps on happening, right? And for that, what other thing can go wrong is, the person A and B who are next to it, they could be exposed to a touch potential or a step potential, while this thing is happening. Okay, so preventive measures is carry out the work, correctly as per the previous maneuvers, correctly identify the grounding location, check for the absence of voltage immediately before the grounding. Do not touch the equipment conductors during the installation. Again, see the cable that is being used for grounding, it needs to be rightly rated, right? So that in case there is a short circuit, it can effectively carry out the fault current for the time of disconnection, say 1 second or 500 millisecond. And the insulation of this earth conductor is basically a mechanical insulation. So never touch this earthing conductor while somebody is earthing, because you could be exposed to high voltages. Okay, so that is step 5. Talking of step 6 is, now you protect from adjacent live parts. Okay, so once the initial risk assessment is completed, determine the likelihood of exposure to the adjacent live parts if they are located inside the vicinity zone of, or the limited approach boundaries of where you are working. Okay, so in many situations you could find yourself, you're working in a cubicle and that is partially de-energized. However, then you need to identify the conductor that can still remain live and determine the best approach to protect yourself. There may be a situation where you are going to work on a de-energized equipment, but there are bare and accessible low voltage conductors which will remain live. Okay, so you need to think about all those adjacent live things. Okay, you can use appropriate insulated protective equipment, gloves, mat, poles, tools, or shielding, shielding inside. Where exposed energized conductors are present, minimum clearances needs to be established as per our CEA regulation, and this shall be maintained by suitable screening or barrier of insulated shrouds. Okay, now you need to take special precautions and adopt other safe practices where minimum clearances cannot be made. Okay, and while doing this, and this happens typically when entering the switchgear cells or even trying to apply screens and applying portable earths. Now that covers our 6 steps to safety. Once you have done all these 6 steps, okay, so step 1, you prepare for the work. Step 2, you identify, barricade the location. Step 3, you disconnect all sources of supply and secure against reconnection. You have checked for the absence of voltage, and you have put the earths in so that you have drained down any kind of residual voltages or residual power. At the same time, protected yourself against any accidental energization, and you are protecting yourself from any other adjacent live part. Once you do this, the last step what you need to do is complete the permit to work and walk the permit. So what does it basically mean? Now that the safe area has been established, the final step begins is, you must the beginning work must be implemented, which is step 7. Complete the permit to work and walk the permit. So basically you just go through all the points in your permit to work, which is a document that all the points of isolation has been made, the earths have been applied, the local earthing, the main earthing, the drain earthing. You've gone through the single line diagram, you have verified the LOTO, and you walk all these things with your team that yes, you have done it. It's not just for you, it's for the whole team to understand. Talk about it. Talk about it with your team. Go through the same with your whole team. Ask any question to your team if at all they have got any concern, because many times what happens is you are the supervisor, you are the in charge, but there are team members who are really working in the ground. They know the actual problem. They can tell you, sir, यहाँ पे कुछ रह गया है, ये इसके लिए क्या करेंगे? Then okay, that could be a concern, or that may not be of a concern. Okay, and this only comes up when you talk to your team, and it gives a lot of confidence to your people. It gives a lot of confidence to your people. Now, as a last slide, I would just like to show you a small video what happens when you work live. Now this is a video from probably Spain or Brazil. I don't know the location, but it's in Spanish. Okay, and let me just play this video for you. So these are basically the utility people who have complied with their safety procedures using appropriate equipment, including face shield, but they have decided that they don't want to switch off the supply and they want to work in live. So working in live come with risk. We at Hitachi Energy, we do not work on live, and we follow strictly our 7 steps to safety. And with that, thank you very much for this opportunity. That's all to you, Rajesh sir.
Mind-blowing presentation. Wonderful. We usually make 7 promises while going for any marriage rituals. Similarly, we have to follow the 7 steps of safety also while working in industries or utility. Very wonderful, and you can take rest of 2-3 minutes before I go for the question. And I would like to invite respected Esapau sir. He is with me. Kindly share your view about the presentation. Then we will take some questions. Kindly unmute, sir.
Okay.
Sir, kindly unmute. Yeah.
Yes, yes,
Yeah.
now only I am permitted.
Yes, yes.
Good evening, very good evening, Rajesh ji. It's a wonderful presentation by Mr. Ramaiya, Harsh D Ramaiya from Hitachi. It's a very wonderful presentation on safety aspects. Actually, detailed lotto procedures for safe work practices in electrical installation is a must. Yeah, actually, the clear concept of 1 lakh, 1 key, and 1 person, it's really impressive because always keep the key in your pocket as your life. You imagine that the key is your life and keep it in your pocket. You have the lock, you have the key, and you should use it. And another thing, non-observance of lotto practices is just like inviting accident, because in every installation, the hazards are already shown, and we only have to avoid by abiding by the proper procedures, especially the grounding practices that he has explained in the slides are quite impressive. One should use, because while putting the ground itself, they get some problems. Some trapped charges are already there, and instead of putting the ground terminal first and then hooking the hard stick of earth rod to the conductors, these are minute procedures are also there. I should once again appreciate the presenter and the organizer for a very good, wonderful presentation today. Thank you, sir. Thank you.
Thank you. Thank you. I don't want to lose the opportunity to talk with Davis, sir. He's also with me. He's also expert. He's a trainer. Sir, kindly unmute and say a few words. Sakeji, kindly allow Davis, sir, to unmute.
Yes, sir. 1 second. Answer.
Still he is muted.
He can unmute himself.
Sir, kindly unmute.
Mr.
You unmute everyone because yes.
Yeah,
Now,
yeah. Okay. Yeah. Great. So I hope you are
yes,
able to see
you're
me.
audible. You're audible.
Okay. Thank you. And Dr. Rajesh ji and Mr. Ramaiya for an excellent presentation. I think it was very useful. And yes, as Mr. Rajesh has mentioned, I am also a trainer on electrical safety. Worked with Siemens for last 35 plus years, and now I am a consultant. So once again, thank you, Ramaiya, for presenting it.
Thank
now, these 7 steps, what you are described, yes, I think everybody need to not only by heart it also to practice, because many of the organization where I have come across, where Siemens is also working on many places, many projects, maintenance, and then so on. So what we come across is basically it is all there everywhere. It is not there, the documentation is not available, but in practice, people are not doing it. Now, if I ask you a question, just to get an insight, can I, Mr. Ramaiya?
Yes, please. Yes,
Thank
please.
you. Yeah. So we have been talking about arc flash very rightly, and then incident energy, and then so on. The one point which you touched upon was quite interesting was the discharge rod. What is the rating of the discharge rod and that particular lead what you use? Is it that it is going to carry the fault current even for milliseconds or microseconds, what you're talking about? Or is it something, can you give a bit insight on that, because you are a specialist in arc flash study?
Sir, see the earthing rod that we use, earthing cables that we use. Okay, there is a insulation part. There are some 3 parts. One is the insulation part, one is the connector, and third is the cable that connects to the ground. So first thing is, you connect that cable to the ground first. Okay, you wear the proper arc flash rated clothing and voltage protection gloves. The rod has to be rated for the voltage where you want to earth the system.
Right. Okay. Absolutely.
So the rod specification, rod is a different component and the cable is a different component. So rod has to be rated for the voltages. If you are doing it for 110 kV, you do it, you have 145 kV of nominal voltage level of the rod, which must be calibrated every 2 years or whatever is as per the IC standards. and the conductor that you are using for earthing, it must be good enough to carry at least 1 second of the short circuit current capacity of your power system. So every power system is different. Okay, so different power system have different short circuit capabilities, and you use the earthing conductor good enough for that particular circuit. So you need to note it down at the beginning when you are doing your step 1. When you are preparing for work. Okay, today I'm going to service this particular equipment. The short circuit levels, I know they are 25 kV, they are 12 kV, or 12 kiloamperes, or 25 kiloamperes, or even 40 kiloamperes. But when it goes very high, normally in the switch yard, you have got a permanent earthing switch. So that becomes a part of your system. Then what you do is, if you are in a switch yard, then you use your main earthing switch, and then you don't need that much because you are totally covered with the earthing switch. Then you use what you call as a temporary earths, that is the drain earths, only for discharging any kind of induction effect. That is what you do, sir.
Okay, thank you. That brings to me another one more insight from you. Suppose I am working in a 11 kV or a 33 kV panel, So is it possible, practically possible, to have two different discharge rod with a different rating? I think practically, if you go to any substation where there is a 33 kV, you will, very hard to find some discharge rod in a proper condition. That is a different topic. But then let us talk about a discharge rod available, but I don't think it is practically feasible to have two discharge rod at one substation. So
I think, sir, the discharge rods, what we use, we have, it's like multiple pieces. It's like, you connecting one rod with the other. It comes like one part is rated for one.
No, insulation part is perfect. I'm talking about short circuit, the fault level capacity of conductor, what you're talking about. That is going to be a question.
Conductor. Sir,
conductor size, because that is going to be a big challenge, because
you can go with the more higher you go, the more heavier the cable becomes practically.
Absolutely.
Okay.
Absolutely.
So you must, to some level, you could say, I will only have 2 earthing conductors. So wherever you are going, you just don't jump into, from front that, okay, maybe 10 days down the line, I have to go at this site and I'm going to do my work here. So you should have maybe 2 pieces of earthing conductors. One for rating A, one for rating A plus X, something like that.
Okay. Thank you, Ramaiya, and
thank you,
Dr. Rajesh, for giving this opportunity to interact. Thank you very much. Thank you.
Now, I don't want to lose opportunity. I would like to invite Pathak Sahab, if you are available, kindly say a few words. We want to have your expertise on that. I think he's not here. Sunil Sarde Sahab, kindly say a few words. It is the right time to talk to you.
Yes, sir. Thank you, Harsh, sir. You have given a very good information regarding the electrical safety. Again, Davis sir has raised some doubts, and similar doubts I do have also. Definitely, when we are working with the 400 kV system, or 66 kV, or 132 kV system, or 33 kV distribution section, what should be the exact size of the conductors? Because in 400 kV substations, I was recommending the 16 square mm copper cable, but whether that is sufficient or not, whether that is to be used, what should be the conductor size at 33 kV level, all these questions needs what should be the specification for particular discharge rods? Because whenever accident takes place and the electrical inspector comes there and he sees the condition of the discharge rod, then he is not satisfied with that. So what should be the conductor? What should be the specification for this, so that all the utilities should use discharge rod?
I would like to add something here. Actually, in my system, what I have done, I have given one minimum cross-sectional area of 400 square mm to take care of the fault current up to 50 kiloampere in my systems. And in switchyard, whenever we start any activity, we recommend people to do with that 400 square mm insulated cable as a temporary earth switch, earth system, while doing the something in the system as a maintenance. for my system, I have given recommendation of 400 square mm minimum size that can take care up to 50 kiloampere without any problem.
400 square mm.
Yeah.
So that is a big cable, sir.
It's a big cable. Actually, when you are working at 400 kV systems and the fault level is up to 63 kiloampere at some places, you have to have that much of size. I know that is very bulky, but you don't have any option. In that case, you can use two cable in parallel of 200 square mm each. But you will have to have that 400 square mm to take care of the total fault level if you want to survive.
Yes, yes, it is okay. But whether there are any specification regarding this discharge rod? And
Sir,
cable
as I mentioned, sir, see, discharge rod, the rod itself should be rated for the voltage where you are working. So if you work
Okay.
for 33 kV, okay,
Okay.
now there are in market, if you go and search, there are rods where you can just keep on adding the rods, the length of the rod, so that you get the necessary insulation. Okay, so one rod could be as good to protect you against, say, 30 kV. So you if you are working with 33 kV, you attach two rods, okay, two rods, and then check it. Or the voltages, or check the you do the earthing. Okay, so that the rod specification goes same as the voltage level, the system voltage level.
Right.
Now coming to the conductors, as I mentioned, sir, your conductor should be sufficient enough to discharge the fault current for 1 second. For 1 second, because most protection system will operate in 1 second. So wherever, like if you have your own industry, right? You know what is the fault current in your industry. If you are a utility, part of utility, you know what is the fault current in the section where you are going to work. Okay. Now, if you are going to a customer, like if you are a third-party contractor and going in a customer's premises, you can always ask them if they have any earthing conductors, earth conductors of any particular sizes. The size you require, as Rajesh sir said, you need to have good enough to discharge the current for 1 second. They have standardized it on 400. I would say if you look into the manufacturer's specification, if that particular cable, okay, over here there are two parts. There are some cables which of a lower cross section you can use it for earthing. So in case there is the conductor becomes live, okay, what will happen is the condition of the cable will not be good enough to use it again. So it has crossed over maybe 90 degrees or something for that temporary 1 second. Now that cable you can discharge, but then you go with a smaller cable's cross section. Then you go with a higher cross section that you can repeatedly use it. That means the life of the cable is still sustainable. So you go and check the manufacturer's specification that you need for a fault current of say 30 kiloamperes or 25 kiloamperes, and what manufacturers are offering for what kind of cables they're offering that can sustain 25 kiloamperes for 1 second. Some could be reusable, some could not be reusable. And the one that are not reusable would be of lesser cross section, lower cost, and lightweight. That is what you can go and research it about.
Though another doubt in my mind is that after earthing this section and after putting the earth switch, then we are putting the local discharge rods. So their cable should also have the same capacity.
No, sir.
No,
not required.
That is not required.
Not required. See, that additional earthing, which we call as a drain earthing, is mainly to protect yourself or bring an equipotential surface to protect against any kind of back discharge from test kits or induction effects from the adjacent line. The main this main earthing which Rajesh sir is talking is whether you are in the center of this transmission line or a distribution line, or in an industry where it's not overhead or you don't have any earth switches. Okay, like the 33 kV indoor panels. Okay, at that time you don't have these earth switches. Then you require the big cross-section sizes of the cables.
Yes, very true, very true. When you are not sure about the fault level and you are in between the circuits and you don't know the position of the actual earth switch in the system, in that case, you need a bigger size. If you have provision of the earth switch, then you can use a smaller size cross-section area because the function is different of that temporary earthing. Now I would like to invite questions. Paul sir have some doubts. He has raised his hand. Kindly ask your question.
Actually, Mr. Ramaiya has explained clearly about the voltage rating of the earth rod. The problem is regarding the short circuit rating of the conductor. See, we have already established that a specific formula I by S is equal to K by 2T. That is surface area, area of cross section of a conductor is equal to I root T by K, where K is the conductor material constant and T is 1 second as
True. Sir, based
Yeah.
on this formula, I
Yeah.
have come to that 100 square mm.
Yes, another thing we know the fault level of the particular substation. All 110 kV, whether 110 kV, 132, 400 kV, 230, the fault level is arrived by the system studies. We can make use of that fault level and apply that formula to arrive at the area of cross section, mainly at the main conductor earthing. That means main discharge earth rods. We
True.
did not have what do you call size disproportionate. We should be confident of the size. We should estimate according to the fault level prevailing at the substation.
Very rightly said.
Right, yes.
Now
Thank you.
I invite all the participants. If you have any question, you can unmute and ask the question. We will take 3 questions. If you have any question, please, I welcome everyone. Kindly unmute and don't hesitate. Ask the question and take benefit of the experience of Ramaiya ji.
Somebody has posted on the chat like saying VN Rao sir has said that, what is step 2? So step 2 is nothing but, you barricade your area and
Right.
you keep it secured, wherever you are working. You identify the area where you are working, barricade it properly, put proper labels so that unauthorized entry can be prevented. At the same time, it clearly, you get an identification that you are only working in that zone. You don't venture into any other panel or any other bay which could be live. So that is step 2.
Any more question to ask? In case there is no question, I would like to say thanks to Ramaiya ji and would like to close. Kindly ask your question.
Sir. Hello.
Yes, sir.
Yes, Mr. Praveen, please.
Sir. Actually, I'm working in AP transfer, sir.
Yeah.
We have 220 kV substation. I'm working in that substation. While we are doing some maintenance work in 220 kV yard, we are taken MC. Actually, while tripping the circuit breaker of 220 kV, it is having 3 limbs. 2 limbs tripped properly, 1 limb not tripped. So we have done one thing like we have tripped the other end of the transmission line breakers, and we have opened the isolator of the our end. Is it okay to do like that, or is there any another way to do it properly? Because we are troubling from bus bar production with operator or not.
Rajesh, can you just repeat the question? I didn't actually get it.
Yeah. The question is very simple. Suppose there are 2 stations connected with 2 breakers.
Okay.
What happens when you going to start any maintenance activity? You have to trip both the breaker on the both hand. Actually, at the second end, the breaker trip. There are 3 poles in the breaker. All 3 poles tripped at the second end. But at their end, what happened? 1 pole stuck in between the position of close.
Yes,
It
sir.
couldn't trip. It was live. And whereas 2 R and B were opened and Y was still in the circuit. In
Yes.
that case, how to start maintenance activity? Am I right?
Yes, sir. And also, it is actually a transmission line. One phase is charged condition. There is a probability of fault occurring in transmission line in that phase. Then we are troubling whether bus bar production act in our substation or not, because that line breaker is not tripping. So we are for isolating the transmission line, we are directly open the isolator of that particular transmission line. Is it okay to do like that, or we have to take complete bus LC?
Okay, I can tell you based on my experience that depends on the length of that circuits.
Okay.
If that length is quite less, there will be very low charging current after switching it on from the second end. If the
Okay, sir.
rating of 100 kV and the line length is quite big, it is
Okay.
very dangerous to earth from your end. and
Okay,
you
sir.
will have to shut down a complete bus to isolate it.
Okay, sir. Thank you, sir. Thank you so much, sir. Thank you.
Okay.
Okay. Just answering the first part of his question, that if the pole of the breaker gets stuck, like our step 3, our step is to see effective disconnection. So if it is an AIS, of course, you will open your isolators, that you can see the effective disconnection there. The air gap is good enough. And if it is a GIS or a other kind of medium like vacuum or anything, in that case, you really need to take care of opening that particular pole, if at all there is no disconnector in between. Okay,
True.
if there is a disconnector, just open the disconnector and make sure that you have locked out and tagged out on the disconnector. And then probably, you can go ahead with the maintenance.
Great,
Okay,
great.
sir. Thank you, sir. Thank you so much, sir.
And as there is no question, I don't want to miss opportunity. I would like to invite KK Murthy Saab, kindly say a few words before I end the session.
Sir, can I add one thing?
Please, please.
Now regarding this busbar operation and all that, opening of the breaker, as a safety point of view, whenever we open the breaker, then first we shall see the check before opening check the currents before opening the breaker and after opening the breaker.
True.
If there is any pole stucking, there will be some current, and in that case we shall have to take the more precautions, because we have experienced some faults and some accidents that breaker pole was stuck, but that was ignored, and after opening of the breaker, the isolator was opened. That time there was a very much there was a very high flash over, and there was a burning of the blades and injuries to the operating staff also. So after opening the breaker, see that what is the current before opening the breaker and after opening the breaker, and ensure that the current has become zero in all 3 phases. And accordingly, we shall have to take the precautionary measures. Okay.
Thank you, sir. Thank you. And now, time to invite KK Murthy Saab, kindly give your blessings, then I will end the session.
You don't need any blessings, my dear. God is there to bless you, you see. And as far as his question was there, that can the isolator be opened? It cannot be opened like that, because the line is charged, so capacitive currents are there.
Yes, yes.
So once you open it, there'll be this thing, very big flashover. I have seen all this in my service period, you see. So I can give my opinion on that. And second thing, while discharging this thing, what Mr. Ramaiya has said, that you should have the voltage level of the this thing, discharge rate equivalent to the voltage level of the system. That is not possible. See, it is not a hotline rods. See, they are simple rods, but only thing is you have to first connect the bottom terminal to the earth, then hang the rod with a G-clamp and tighten that G-clamp. So that is how I can tell you. And as far as the safety in EHV system is concerned, I have presented a paper in CBIP in 2019, and that was appreciated by many people. That was on safety in EHV substations. So if anybody wants, I can definitely send it to them.
Sir,
So,
kindly share that paper and I will circulate
Yes, sir.
among all the persons.
And I must appreciate Mr. Ramaiya for his very, very interesting presentation.
Thank you, sir.
And
Thank you, sir.
of course, great Dr. Arora, he is the person who brought you here, and he is day and night he is busy in this in disseminating the knowledge. You see, that's a great job he's doing to the fraternity of these power engineers.
Thank you,
With
sir.
this, so thanks a lot, and I hope you will again call some expert in webinar and enlighten us.
Thank you, sir.
Thanks a lot.
Thank you.
Thanks.
And again, I would like to thank Ramaiya Saab, Harsh ji, thank you very, very, very much. And you accepted my invitation and you spared your invaluable time.
Sir, it is my honor,
More
sir. Thank
experts
you.
to come for dissemination of knowledge on this igniting power engineers. With that, thank you very much. Thank you, everyone.
Thank you very much. It is my honor. Thank you. Thank you once
Thank
again for inviting
Thank
me.
you.
It is my honor. Thank you.
Thank you, sir.
Thank you.
And thank you very much to all the audiences. Thank you.
Have a nice time to all.
Thank you. Thank you.
Thank you. Thank you.
Thank you, everyone.